Okay, welcome back. Okay, I was saying that for polynomial regression, okay, for linear regression, in order to calculate the standard error of estimate, this is the formula. Let me just go to the formula. So this is the formula to calculate the standard error of estimate. That's for linear regression. But for polynomial regression, this is the formula to calculate the standard error of estimate. So I was saying that is actually the same thing. It's similar to linear regression. But in the case of linear regression, m is equal to 1. So if m is equal to 1, you're going to arrive at this standard error of estimate for linear regression. So this when like for m is equal to 2, 3, 4. So these are to calculate it, because remember I told you that we want to be able to quantify the line with fit, if it's actually a good fit or not. So we are going to use another example. Then we're going to fit a second order polynomial to the data in the table. And in order to fit a second order polynomial, so look at this particular. So I told you that we didn't eventually solve it, this linear algebraic equation, but I attempted to solve it. And the way I attempted to solve it was I expressed it in matrix form. So we want to get this coefficient, right? We want to get the M2 coefficient. We want to get the M coefficient. They want to get the C coefficient. And so given the question, we need to construct a table. So first of all, you need the summation of x squared. So this is the x squared. So this is the summation of x squared given by 55. You need the summation of x cubed, So this is x cubed. Just this your x raised to the power 3. Then you have this column. Then sum all this together. You arrive at summation of x raised to the power 3. So we need summation of x raised to the power 4. That's why we have this column now. So you just raise to the power 4 all these coefficients you have here to 5. Then you arrive at this. Then you sum it together because of this summation sign. You arrive at this. Then we need summation of y. Summation of y. So you sum the y column together, you arrive at this. You need summation of x. So you sum the x column, you arrive at this. Then we need this summation, x multiplied by y summation. So this is the column. So multiply x by y, then you will sum all of this to get this value. So this value is equal to this particular value. Then we need this summation, we need this y multiplied by x squared. So this y multiplied by x squared. So you square this one, then you multiply it by y. Then you arrive at this column. And you arrive at the summation because it's a summation. So this is the number we are interested in. So we already have all these coefficients now, which I've just explained. So we have all of these coefficients. Now, I'm going to put it in matrix form. So what I have here, is the same thing as the values I have here. It's just that I calculated the values for this particular question. Then I just put in all the values. So this was the value we calculated for the summation of x squared, 55, 55, summation of x squared, 55, summation of x squared, 55. So this is where the 55, 55, 55 comes from. So it's from the table. The summation of x cubed is 225, which is here. Summation of x cubed is 225. Then x summation of x raised to power 4 is 979. Then the summation of y is given by this. Summation of x multiplied by y is given by this. Then the summation of y multiplied by x squared is given by this. So, like I said, you can use different methods to solve it. So, last topic was solving linear algebraic equations. So, I will not go through the algebra. So, you can try to do it for yourself. When you solve it, you're going to arrive at C is equal to this, M is equal to this, and M2 is equal to this. So given these particular values we've solved for, remember we are trying to fit a second order polynomial, and a second order polynomial is given by this expression. And we already have the values for M2, M, and C. So the values we arrived, we are just going to put it into the equation here. So M2, we solved it low. I skipped the step. So this is M2, this is M, and this is C. So this is the model for the second order polynomial we arrived at. So I have a new table. So from here is the previous table, but I'm including this column because I want to calculate the standard deviation. Then I'm including this column because this is our model. So I want to compare the one we were given, the value of y we were given in the question, with the model we derived. So this is the sum squared of the difference between the measured values and the model. And remember, this is our SR. We want to drive this one to 0. If this one is very close to 0, then we know that we have a perfect fit. So in order to calculate the standard error of estimate, we just put in the values we already got. Then to calculate the coefficient of determination, which is R squared, we arrive at this. Then to calculate the correlation coefficient, we arrive at this. So remember I told you that for a very good fit, the correlation coefficient should be very close to 1. So since this is very close to 1, we know that we are a bit, our line is a very, very good fit. And this should be close to 0. So it's kind of close to 0. So we know that this is a wet line. So when we plot x as a function of y, which is the values we got in the, which is the measured values in the question, then we plot this as a function of this. Then we are trying to see just for visual inspection. So when we do that, so these blue points are the points given in the question. Then this red line is the line we fit through the point. So from the line, we can see that it provides a good fit to the data. So let me go to Excel now. So we have actually used a so all the calculation we're doing it by hand. So we need a computer program in order for us to be able to do this, all the calculations we've made, in order to be able to do it in using a computer program. So I'll be using Visual Basic. I'll be using Visual Basic Excel. So let me go to Visual Basic Excel. Right. So I'm a Visual Basic Excel. So we want to be able to write a computer program that is going to be able to do the linear regression for us, and to be able to calculate, to be able to plot the line and calculate the coefficient, the slope, to calculate the intercept, and to calculate the different measures like the standard error of estimate and the correlation coefficient. So this is the computer program and in Visual Basic. So this is our definition. So sheet 7. So I'm just telling the computer program to use the data that is available in sheet 7. Then this is our X and this is our Y, because we need X and Y for linear regression. So I'm telling Visual Basic that it should take in the values that are in A1 from A1 to N. Then for the X term, then for the Y term, taking the values from D1 to the last, to N, to the last value. So if I'm in Excel, so it should start from, it's actually starting from A2, then to the last value, which is N. N is 7. 1, 2, 3, 4, 5, 6, 7. So you have 7. That's why I put in 7 here. That's why N is equal to 7. Then it's starting from range A1. So I'm offsetting by A. So A is actually from, it's going to start from A2 because A starts from 1. So when you offset by 1, you're actually going to the next, row. So it's actually going to start from A2. So here it's going to start from B2. Then it's going to go to N. So the last value you have. Then this, you have a do loop here. This is the equation that calculates the sum of X. So this is the equation that calculates the sum of Y. This is the equation that calculates the sum of X multiplied by Y. So you have X multiplied by Y, but it's a summation, so it will keep on summing as the loop keeps going. Then this is the line that calculates the summation of X squared. Then is a loop, is going to keep on looping from 1 till N. In order to calculate the different measures, so this is the ST. ST is the standard deviation. Then SR is the sum squared that we want to minimize. So this is how to calculate it using computer program. Then in order to calculate the error estimate, the standard error coefficient, so this is it. So is SR divided by N minus 2 raised to power, everything is square root, but in computer program, you have raised to power 0.5 to indicate square root. Then to calculate the coefficient, regression coefficient, is simply ST minus SR divided by ST. So this is the equation, this is the code to calculate the linear regression. Then after that, we've already calculated for A0 and A1. So A0 is the intercept. Remember the formula to calculate the intercept. That's the mean of the Y mean, then the X mean, then this is the slope. And this is the formula to calculate the slope. So you need the sum, the N, that's the number of terms, then the sum of X multiplied by Y, the sum of the X's, the sum of the Y's, then the sum of X squared, then sum of X multiplied by sum of X. So this is the equation to calculate the slope, and this is the equation to calculate the intercept. So when you've calculated for A1 and A0, the next thing is to derive the line, to get the line. So to get the line, you need A1 and you need a naught. Then you take the values of x in range A1. So this loop is to calculate the line of best fit, to calculate the values. Then this particular last set of equation is just to draw the line. It's just to draw the line through the straight line through the data. So I'm in Excel now. So I'm in sheet 7 here. So if I go back to Visual Basic, I'm always on sheet 7. You can see sheet 7 specified here, then sheet 7 specified here. So I'm telling Visual Basic to go to data in sheet 7. That's why I have sheet 7 here. So this is a subroutine. All I just need to do is to run the code. So I just press the run button. Once I press the run button, so the code to calculate, to do all of it is already there. So once I click this run button and I go to Visual Basic and I go to Excel, sorry, at sheet 7, it's going to calculate, it's going to give me the column for the straight line. Then this is the slope of the line. Then the next one is the intercept. Then the next one is the standard error of estimate. And this is the correlation coefficient. So it's in L, look at this L, so L from L2 to L5. So in the code, I have it here. So I'm saying that you should write all of this at from L2. That's why it wrote the slope of the line, the intercept, the standard error of estimate, and the regression. That's why it wrote it at the L column, starting from L2. Then for all of these, it is at cell E. So if I go back to the Visual Basic program, I'm saying that at the E column, it should write out the line of best fit. So this is the equation that calculates the line of best fit. Then you should put it in the E column. Then so it's going to automatically generate a plot for you. So you don't even have to plot it with the code. So this is the blue points are the points given in the question, while the red line is the point that is the line, is a straight line fit through the data. So let me delete it. Then use another, let me use this. So this was the second example we did. So let me just copy the line and let me paste it. Okay, it's giving me a different value. So actually, so let me just use this P. So I want to use another example to in order for using the same program. So let me delete these results. So now I want to generate the chart for the best of the line of best fits using the second example. So this is the model, the mathematical model. Then these are the measured values. So in the Visual Basic code, all I just need to do is that in the n is equal to 15 here because you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So n is equal to 15. All I just need to do is to change this n to 15. That's all I need to do, to change this n to 15. Then once I run it, it's going to give me the line of best fit. So at sheet 7, this is the line of best fit, the values. So this is the these are the slope, the intercept, the standard error of estimates, and the regression line. Then here is going to actually plot the line based on the data. So this is how to do it using Visual Basic Code. So if you want to plot it using MATLAB, I think the textbook has MATLAB. So you can go through the textbook to look at the code to plot the to do the same thing using MATLAB. Okay, so that's the end of the class for least-squares regression. In the next class, we are going to go into interpolation. So interpolation is you are trying to predict based on the curve you've fitted through the data. You want to make predictions that given the model of given the data points and the model you developed from fitting a line through the data, you want to be able to interpolate, you want to be able to make predictions for points that are not on the line or for points that are not given as part of the data set. So that's the next topic, interpolation. So we are going to be stopping